We have 1 more minute before we go live. Ram, can you have we enabled the YouTube also, Ram?
It's enabled, sir.
Okay. So Ram, we still have 3 more minutes. So anyways, while we, I will, before we start, do our traditional 3, 2, 1 thing. We still have 2 more minutes. So requesting the other speakers, if they can put, switch on their videos, please.
So our video is coming?
Yes, sir.
Yeah, Dr. Chaubey, I can see you, but I think Sujith and Colonel.
Sujith is live, sir. Sujith
Okay.
is there. Colonel is not.
Yeah, I'm there.
Yeah.
Yep, perfect.
But we
sir, shall
not
I-
able to see the screen. It's on a screen, it's not coming for everyone.
Okay.
No,
So
that is because the screen sharing is enabled. We will stop the screen sharing shortly.
Right.
so Ram, we still have 1 more minute to go. So why don't we go live?
Yes, sir.
Because I already have some few messages from people who are waiting. So let's go live.
At the count of 3, 2, 1, we go live. 3, 2, 1. We are live now.
So we will allow a minute for all our attendees to settle down before, I start dot at 4 p.m. Requesting all our attendees to please settle down. We will start dot at 4 p.m. So we are starting the webinar. So Ram, 3, 2, 1. A very warm good afternoon to all the attendees, and I welcome you all to the 4th episode of the season 2 of the IWET series. Since this is the first episode for 2022, let me start by wishing all my speakers, panel members, and all the attendees a very happy new year. We have always tried to bring new elements and additions to the IWET series for our content. And today it is we are extremely privileged to have a book discussion session, and we will have a good discussion with the author of one of the leading books that have just been released in the wastewater space. So without taking too much time, I would now like to invite Ms. Yasmin Dubash. She is the Trade Commissioner for the Consulate General of Canada. And I would like her to introduce her keynote address, please. Over to you, Yasmin.
Thank you, Mr. Kailash Shirodkar, and welcome everyone. We are very happy to introduce Canada and its technologies at the IWET series. And with that, I would like to introduce Mr. Francis Paradis. And Mr. Francis has nearly 15 years experience in the Quebec Public Service, and he has been director of the Quebec Government Office in Mumbai since September 2019. So the Consulate General of Canada and the High Commission work very closely with the Quebec office to advance our interests in India. So Quebec, as you may know, is one of the 13 provinces and territories of Canada, and it is the largest province by area and the second largest by population. So welcome, Francis, and over to you.
Thank you very much for the introduction. So namaste. आज मुझे आपसे बात करने में बहुत खुशी हो रही है. Man hindi sikrahahun isliye mere galat ucharanko kripaya kshama kijiye. Water is one of the most important natural resources, not only from a social and environmental point of view, but also from an economic development perspective, since it is used, among other things, for irrigations and maritime transport. Unfortunately, water is also a non-renewable resource that needs to be taken care of. Considering its increasing rarity, it should be mentioned that Quebec is one of the most privileged territories in the world in terms of the amount of fresh water found there. Indeed, the Quebec territory contains 3% of the world's freshwater reserves spread over nearly 500,000 lakes and 450,000 rivers of different sizes. This proportion is even more impressive when we consider that the demography of the territory is only composed by 8.4 million of people. Particularly because to the St. Lawrence River, 10% of the Quebec's surface area is composed of fresh water, making it one of the regions in the world where the resources is the most accessible. This proximity to water resources has enabled Quebec to develop several centers of expertise in wastewater treatment and sanitation, including, for example, the Centers for Research, Development, and Validation of Water Treatment Technologies and Processes. Several universities have their own research centers, thus contributing to strengthening the knowledge and skill of the Quebec's workforce for the freshwater sector. The aim of these centers is to promote the creation of the expansion of innovative water treatment technologies. Beyond its technical expertise, Quebec has a regime of strict water quality standards. The Environment Quality Act and its regulation respecting municipal wastewater treatment works imposes strict quality control on municipalities. It specifically controls their water treatment process and the operation of the treatment centers. These legal standards are aimed at preserving Quebec's waterways and ensuring that purification practices are standardized. In addition to regulating municipal practices, Quebec authorities promote the quality of Quebec waterways to raise awareness among its population to reduce their drinking water consumption. Thus, the Quebec context has made it possible to build a fertile environment for the development and establishment of companies working in this sector. There are several foreign companies that have set up in the province and export their technology and expertise. Think of Quebec companies that are already present in India, such as Premier Tech Aqua, Velan, Acme, and Ovivo, who will speak after me. Let's also think of Canadian Pound of Quebec, which carried out a pilot project in Agra to help clean up the Yamuna River near the Taj Mahal. This is the proof that we can work together to share our respective knowledge and improve life on Earth. These companies specialize in infrastructure and equipment that comply with the principles of sustainable management. And now, water has become blue gold, sought after around the world, and has become a collective wealth. Countries with easy access to fresh water will become strategic allies in the development of our populations. In conclusion, we must reiterate that these companies represent a great opportunity for Quebec's economic partners to strengthen their governance and efficiency in wastewater treatment. We really believe that we can join our efforts to achieve the global goals set at the last COP26. Please have a pleasant session. Dhanyavad.
Thank you, Francis, for sharing this info, and I'm sure the audience would be interested to know the expertise of Quebec companies. And going forward, I think from this session, they would love to interact with any Quebec companies that might be there in India or looking to bring their technology here. So thank you, Francis.
Thank you very much. It's appreciated to be there. Thank you for the invitation to my colleagues from Canada.
Thanks. Moving on, before we move on to the next session, I would request any questions that you might have during the presentations to be put in the Q&A box and not in the chat box, because then it's easier for me to take up the questions during the sessions. So starting with our session today, I would now like to invite Mr. Sujith Kumar, GM Sales and Marketing, Ovivo India, and he's going to talk about the Ovivo silicon carbide membrane technologies and the limitless possibilities that it throws up. Over to you, Sujith.
Yeah, thank you, Mr. Kailash, and thank you, Francis, for the great speech, and I loved the way you spoke about Hindi. Congratulations to you. Yeah. My name is Sujith Kumar. I head the sales and marketing for Ovivo India. I've been in the field of water and wastewater for more than 24 years now. It is my pleasure to be with you here today for IWET webinar conference, and thanks to the Smart Water and Waste World, and definitely to the Canadian Trade Services who gave us this opportunity. We at Ovivo provide process and technological solutions which are sustainable, economical, and innovative solutions for both municipal and industrial clients globally. Our commitment is to deliver the best solution to all our customers and the environment. I'm grateful for the opportunity. Today, I'll be presenting on Ovivo silicon carbide membrane technology, which has got a limitless possibilities. I'll try to wrap it up within 15 to 20 minutes, and thereafter, definitely I would like to have a good interactive session on Q&A. Let me share my screen. Yep. I hope my screen is visible, Mr. Kailash, right?
Yes, it is.
Thank you. Yeah. As I said, I'll be just taking through for 15 to 20 minutes on Ovivo silicon carbide membrane technology, which has got limitless possibilities. The flow of topics would be like, what are the wastewater challenges you have been facing currently, and what are the impact on environment, and what is the need of an R, and the MBR challenges. There have been various other membrane suppliers, like you have got unconventional membrane suppliers. Like, what are the challenges you have been facing, and how Ovivo contributes to the those challenges, and what kind of value addition we bring to the table. That's how the whole topic will revolve today, right? Now, what are the effluent challenges, right? When you talk about effluent challenges, like, you need to treat the water and reuse it. That is one of the challenge. Consistent outlet quality, that has become a major challenge, because there's no. If you see in India, there have been at least in municipal wastewater side or industrial wastewater side, it is not running to the design capacities. It is more on an average. It is 60-65% is the water output parameter what you get, right? You never get the design water quality or the hydraulic flow which is designed for. Footprint has been a real concern, because everyone want the technology to have with very low from right? Stringent BNR norm. BNR is biological nutrient removal. There's a recent, it's not recent, from past couple of years, there have been NGT, National Green Tribunal, has been forcing the discharging bodies, be it municipal corporation or any industries, that whatever the water they discharge to the receiving bodies, it has to have the 10 BOD, 10 TSS, and 10 total nitrogen. So day by day, the discharge regulation is becoming stringent. Plant expansion has also been the challenge, because of the growing population or growing demand. There have been an increase in challenges in augmentation of the existing treatment facility and the plant operation, be it MBR plant or any other plant operation, right? And These are the first slide. What I talked about is the common challenges what you face. If I talk about this, I thought of preparing this slide because we are more talking about industrial wastewater, right? I thought of adding this slide. If you see on the industrial effluent challenges, this slowly biodegradable organic compound and which has got a refractory substance, right? It is very difficult to degrade, right? That is one of the key challenge what you face. The high content of organic and inorganic matter, right? Inhibiting and toxic compounds, right? When you have this inhibiting and toxic compounds, definitely biology doesn't work, right? And heavy color detergents with surfactants, right? These are the key challenges what industrial effluent has. And of course, the stringent regulations on discharge norms, right? Now, what is the impact on the environment, right? If you see on the impact on the environment, like if you don't treat properly the water, like you are not doing your job, right? You need to have your social responsibility. You need to treat the effluent to the discharge norms so that the receiving bodies are safe. If you don't treat, the dissolved oxygen depletion will happen to the receiving bodies. You will see the physical change in the appearance of the receiving bodies. Eutrophication happens, right? If you don't do the DNR nutrient removal is not done, the eutrophication will happen to the receiving bodies. Don't forget, this water is coming back to you. Once you send it to the receiving bodies, it is coming back to you. So thus, there is a health risk to the humans and increased water purification cost. Also, you have been investing so much of it and you don't operate the plant properly. You don't select the right technology and you end up an increased water purification cost as well. Okay? Now, what is the need of an hour? The need of an hour is like you need to have sustainable wastewater management, choosing a right product and technology which is key. Recycle and reuse. This should be the mantra for whole of India, at least for the industrial clients. And optimize process design. Definitely, you can't have a liberal design. You need to design your process quite optimized, which is workable solution. Now we talked about on the challenges, right? What is the need of an hour? Right now, I'll get into an MBR system, which is our today's topic, right? I'll talk about MBR system and its challenges. Now, what is an MBR, right? An MBR is a membrane bioreactor. It's a part of the system, right? It's coupled with your activated sludge process and a filtration system. That is called as MBR, membrane bioreactor, right? It is coupled with your activated sludge conventional treatment process itself. If you see the typical MBR design, you will have the screens coming in. At the inlet, you have the screens of 1 mm fine screen. If you intend to treat the water to the biological nutrient BNR limits, let's say BNR 10, 10, 10, 10 BOD, 10 TSS, and 10 total nitrogen, by default, you need to have this anoxic tank, right? And you will have an aeration basin. It'll be a 3 steps of process: anoxic, aeration, and membrane. Right now, what does aeration does? In aeration, usually you degrade the BOD, right? Converting it to CO2 and water, right? Whatever BOD comes in, biological oxygen demand comes in, right? You give the oxygen, right? You cultivate the bacteria, right? And degrade it, right? And in the same basin, you also do the nitrification process. Whatever the ammonia which is coming in, again, you need to blow in the oxygen into the system, right? And all the nitrates have been converted to nitrates, right? And that water is going back to your anoxic basin. When this NS3 is converted to NO3, you need to convert that to NO3 to NO2, right? For that, you need to have an anoxic condition without the presence of oxygen. So you have this anoxic basin, which is typically 1.5 hours retention time, right? You just convert that to a nitrogen gas, right? It's a typical system. You talk about any treatment plants, MBR, this will be the typical flow sheet which you would find. Right? Now, this is the basics which I talked about. People who have worked on MBR, right? If they think of MBR, they will feel that it will deliver the reusable quality, right? BOD 5, less than 5. TSS less than 2, turbidity 0.2. Great, right? It is fantastic, right? And people also think, right? MBR is known for less footprint, right? Definitely, right? If you compare with the conventional treatment solutions, right, MBR will have very less footprint, almost I would say 40% less, right? For if you go with an MBR, that's what people always assume, and definitely they also think about capacity augmentation, small footprint, right? Retrofitting ASP to MBR or for the recycle. So this is what people's mind would crop up, that if they think of a MBR, these are the things which would happen, right? But it could be challenging, right? Membranes could be challenging. Now, what are those challenges? I'll just address on the challenges and how Ovivo add values, right? I'll talk to that later. Now, these are the people who have used conventional membranes, MBR, membrane bioreactors. They knew they can easily connect to these wordings, right? They will see there's a TMP limitation. Quickly, their TMP gets increased, transmembrane pressure gets increased. Premature fouling happens. People say that you need to do the cleaning once in, let's say, 3 months, right? You end up cleaning once in 15 days or a month, right? Durability and robustness. People say this has got a durable life of 7 years, but they end up to something else, right? The actual practical scenarios could be something else, right? Premature replacement, as I said, usually the replacement for conventional MBR, warranty for conventional MBR, people say it's 5 years, but they will end up replacing very quickly. Premature replacement happens. Permeability is an issue. Recoverability is an issue. When I talk about permeability, if you design a system of, let's say, 1 MLD MBR system, within 3 months of operation, you will see there is a flux decline in polymeric membranes, which is proven. And Ovivo is doing this business for more than 2 decades. I'll catch up on that later, what we do, right? Permeability has been an issue. Recoverability is one of the major issues. Once, see, any membranes are bound to fall, bound to scale. The recoverability is a challenge, right? If you're not able to recover those membranes with help of cleaning and bringing back membranes to the original position, then it's a really challenging situation. Chemical susceptibility, you will have you don't have a wide range of acceptance. Like there is a limit, like 3 to 11 pH. That's it. That is the limiting factor for any conventional membranes which are available in the market, right? Now, how it affects, I'll just brief on those, right? Now, what are the operational challenges? Definitely, TMP is one of the operating limits. If you see the top slide, those are the in the vertical side, it's shown as membranes. Like when the membrane is clean, you get a clean flow, right? Eventually, when it reaches to 45 days, right, you have to do the cleaning, right? When you keep on doing repeatedly, right? When you keep on doing repeatedly, when it reaches 3 psi, your membrane would get damaged. When you intend to do the cleaning every 45 days and the frequency is very fast, then the membranes tend to damage, right? Now, material dictates the TMP limits. Because these are polymeric membranes, right? It cannot handle more pressure, right? And hence, like it cannot handle more pressure. It is highly chemical. It's not susceptible to chemical, right? You will see that this would get damaged very soon. And maintenance challenge, yes, you have this frequent cleaning issues, right? If you see, there are 2 types of cleaning. You do mechanical cleaning or chemical cleaning. Right? In mechanical cleaning, you take out those membranes which have been sludge dewatered or highly fouled, right? You scrap it out, right? Which is very difficult. Or the other option is you need to do the pressure wash, which is not possible for polymeric membrane because there is a pressure limit also. You cannot go more than 3 psi, right? So there is a limit. Or the other option is you go with the acid cleaning and bleach cleaning. Again, you have an limitation of 3 to 11 pH and 5 lakh ppm of the chlorine contact time. As I said, frequent cleaning of any polymeric membrane will lead to membrane damage. The other maintenance challenges, if in polymeric membranes, if you have to do the, let's say, if you have to take out those membranes for some reason, and you have to do some kind of internal maintenance in the tank, you need to make sure these polymeric membranes are continuously kept in a wet condition, because these membranes are hydrophobic membranes. If you don't keep these membranes in a wet condition, the pores of these membranes would get collapsed. Eventually, you will not get the required desired output parameters. Or the other option is you keep on wetting with the water or add some kind of chemical. Again, it adds to the cost. The other recoverability challenge is the membrane life, right? When the membrane is new, as I said, any membrane is bound to fall and bound to scale. You'll see that you operate the system, right? Membrane will get fouled. You clean the membrane will come back to the original condition, and you keep on using it. But after some time, you'll see there is an irreversible fouling happening, right? Once the membrane is cleaned, you'll see there's a flux decline. You're not getting back to the original position. You'll see there's a flux decline slowly after, eventually after 3 or 4 years, right? You'll see those membranes would become irreversible, right? That means you can't do the cleaning and recover those membranes. That is the point you decide to replace the membranes. Now, what are the reasons for sludge dewatering, right? Sludge dewatering is one of the reasons. Organic fouling and the inorganic fouling. This anyway it has to happen because you are dealing with a wastewater, so it is bound to happen. These are some of the picture for fouled and dewatered membranes. We have tried to figure out, like in the market, you'll find there are flat plates, flat sheet membranes available. On the right side, you can see the flat sheet membranes, which has got dewatered. And the middle picture shows the hollow fiber membranes, right? It's very tricky. Once the hollow fiber membranes get dewatered, it's even very tricky to take do the physical cleaning, I would say, because of it would look like a bunch of straw. You cannot pull the sludge in between the bunch of straw, right? And the other fouling, you can see the iron foulings, which usually happens on the membranes, right? See, no membrane is immune to fouling, right? Or no membrane is immune to scaling, right? The key lies with the material and how easily and quickly the clogging can be removed. The clogging can be removed means like recovery. It has to be recovered back. Membranes are bound to fall, bound to scale. The challenge lies like how fast you can recover those membranes and bring it to the original position. Right. On the fouling resistance, like it's a data available in the publicly available, right? If you see, polymeric membranes have got the highest rate of organic adsorption. That means irreversible fouling, right? Among the available membrane, there are many types of membranes available, among which polymeric membrane has got the highest organic adsorption rate. Now, there are new generation membranes available, right, with exceptional properties. Let's see what are they like. Now, what we learned is in conventional polymeric membranes, you have a flux limitation, right? You have a transmembrane pressure limitation. You can't go below 3 psi. Membranes are hydrophobic, so membranes, there are potential chances of membrane pores getting collapsed during the maintenance activities. Fouling propensity is very high. Frequent cleaning, it happens, right? Once in 45 days, you need to do the cleaning. And it's sensitive to the chemical because you can't go beyond 3 to 11 pH. And the warranty, what you get is 2 to 5 years, right? Now, what if there is a membrane available which can take very high flux, 3 times of the polymeric, TMP up to 10 psi, and membrane which is hydrophilic, naturally, which is hydrophilic and oleophobic, which has got a lowest organic adsorption rate, non-frequent cleaning, resistant to chemical. Beyond all this, you have the life of membrane, which is 20 years, and the supplier is giving you warranty for 12 years, right? Don't you prefer that, right? I'll just brief you our experience. Like, we have been in this field for more than 2 decades now. We are totally submerged into the MBR system. We used to promote, Ovivo used to promote polymeric membranes earlier. Slowly, we are moved out of polymeric because we have found future is something else, right? Which I'll share. Usually when customer gets confused, like in market, you'll find many types of membranes available. You have flat sheet, you have polymeric, you have PVD. In polymeric itself, you'll have PVDF, you will have PES, right? You'll have PE membranes, many types of membrane, right? So customer usually get confused which one to choose, right? So I'll just run this video for a minute. I'm sure that you can hear the sound also.
If you can.
Yeah, I'm sure you are able to watch this video seamlessly without any technical glitch. Yeah, we have a new generation membrane which has got limitless possibilities. Like it will overcome the polymeric issues which has been faced. Let's see. Yeah, I'll just talk about the membrane material. Right. If you see the polymeric membrane, it is a petroleum product. It's not an environmental friendly. Polymeric membranes are made out of petroleum product. It's not environmental friendly. Whereas the membranes which we have.
Hello.
Yeah, Sujith voice is freezed.
Sujith, I believe we are facing some technical difficulty at your end. Can you hear us? Can somebody from the Smart Water team do a quick call to Sujith to check?
Hello.
Yeah, Sujith, we missed you when you.
Yeah, I'm sorry for that. Yes, I'm sorry for that. Yeah, well, whatever precaution you take care, you'll end up with some technical glitch. I'm sorry for that. Maybe I missed in this slide, right?
You were in the slide immediately after the video about the materials for membranes.
Yeah, this one. Yes.
Sujith sir, you will have to reshare the slide once again.
Okay, I'll do that.
Sujith, you still have 2-3 minutes.
Yes, I'll wrap it up.
We can see the slide. You can just play it and make it full screen.
Yeah, good to go, right?
Yeah.
Okay, sorry. Yeah, I'll talk about membrane materials. Like polymeric membranes are made out of petroleum product, which is not environmental friendly, whereas the advanced new generation membrane, what we offer, is made out of rocks. It's a simple inert material, right? If at all something goes wrong after 20 years, you have to dispose this membrane. It's very easy to dispose because You can just crush these membranes and bury it. It's as simple as that, right? Since these are all made out of inert material, it's just a manufacturing process. Like we have this SiC silicon carbide powder, which would be extruded to the paste, right? And we expose it to the sintering process with 2200 degree of temperature. We apply on the membrane layer, right? And the membrane modules is formed, right? It's silicon carbide, Ovivo silicon carbide membrane modules, right? The key advantage, key properties of this membrane is, which polymeric cannot compensate, is the 100% recoverability. As I said, the membranes are bound to fall, bound to scale, right? But the recoverability is the challenge, right? You can recover these membranes, right? I'll just brief quickly. I knew I'm running short of time. If you see, as I demonstrated, polymeric membrane needs to be done the cleaning every 45 days. If you go with any silicon carbide membranes, the cleaning would take around 90 days. That is 3 months. That means you are delaying the cleaning. When you delay the cleaning, like you are saving on chemical, right? You are saving on flux, everything, right? But since these membranes are very robust, it's made out of inert material. You can also do the pressure wash, right? You take out those membrane, if at all it is dewatered completely, just do the pressure wash for with 2 to 3 kg pressure. Absolute no issue, whereas which is not possible with the polymeric membranes. And the porosity, right? SiC silicon carbide membrane has got the highest porosity among the available membrane, right? You talk about the PS or CPE membranes, right? That is the reason we are able to push through more flux, like polymer compared to polymeric, 3 times the flux we can take it. When you are able to take more flow within the given area, right? Your footprint also would come down. Right? This is some of the comparison on the flux. Like we apply this membrane to many applications, be it clear water treatment, be it membrane bioreactor, be it thickening application. MBT is membrane biothickening. Be it tertiary wastewater or wet weather system, right? You can take very high flux compared to the any polymeric membranes. It's typical example what we have shown for an 325 KLD of STP, right? You need a polymeric membrane area of 500 meters square, right? With the flux of 0.65 meter cube per day per meter square. This is the typical polymeric design. Whereas if you go with SiC membranes, right, you need just, right, 30%, 40% of it, 171 meter square area, that's it, right? Your footprint also would be very less because we take the flux 3 times. Like there we talked about in polymeric, you can take only 0.65 meter cube per day per meter square. Here we can go up to 1.9 meter cube per day per meter square. Right? And the hydrophilicity, these membranes are hydrophilic. It's water-loving membranes. It's also oleophobic. It aids oil, right? Whereas if you can see the picture, right? If you put a drop of water on the surface of membrane, SiC silicon carbide membranes will immediately absorb that because it's water-loving. Whereas with polymeric membranes, if you put a drop of water on the surface, you'll see that it stays there because it aids water. It's because it's hydrophobic membrane. And as I said, it's also oleophobic. It has also got negatively charged. These membranes are also negatively charged. Particle around the membrane, be it in the submerged membrane, submerged condition, you'll see the particles are negatively charged. The falling propensity will be very less because the particle around the membrane is also negatively charged, and membrane is also negatively charged. It tends to repel. And it has got an exceptional resistance to temperature and chemical. Temperature, it can handle up to 80 degree temperature. It can handle up to pH 1 to 14, right? And the chlorine ppm mass is 50 lakhs, right? We are talking 10 times more than the polymeric. Whereas in polymeric, you can't go beyond 5 lakhs. Here we are talking about 50 lakh ppm mass. Yeah, this we talked about it. And it's easy to install also, right? Like it comes with 160 module, right? One module will have 6 meter square area. You can just put one by one easily. See, this will be tricky where if you want to install this, install the membrane system in the basement where you have the clear height will be very less. In that area, you can have this kind of arrangement. Yeah, and definitely it gives you the superior treatment, BOD less than 2, TSS less than 2, ammonium nitrogen 1, right? The discharge limit, even the SDI less than 3, you can straight away pass this water to the RO system. No need of any further treatment. It's some of the picture of our treated water. Yeah, I'll just sum it up quickly. It can handle up to 45,000 mLs because it has been used for various applications, including membrane thickening, right? 90 LMH is the flux, whereas compared to 25 LMH, what polymeric membranes uses, right? This membrane is hydrophilic membrane and oleophobic membrane. Thus, it has got a low propensity of falling of the membrane, right? And it also repels the oil because it is oleophobic. This is a brief comparison what we made it for the polymeric membranes, be it PVDF or PE membranes, right? And we also offer the 12 years of warranty, right, with 20 years of life. I'll just quickly shift. Yeah, it's the same thing. Yeah, these are our esteemed customer where we have executed our MBR systems. I'll just brief about Ovivo. I haven't talked about Ovivo, what Ovivo is. It's a Canadian company, deals with water and wastewater treatment. We have an expertise of 150 plus years, right? We have grown by acquiring many companies. On the right-hand side, you can see the logos. They are the global brands which Ovivo has acquired over a period of years, right? Now we own those brands globally. And we are a pure water treatment company. It's a technology-driven company, right? We have a host of technologies. This is just a history of how Ovivo have been formed. I'll just skip this. It started from 1991, acquiring a company called Doroliver in US, and thereafter they didn't look back, right? Yeah, we have built an integral platform India. If you see, India is considered as the knowledge and service center, and we are also a center of excellence for biological process. Sitting in India office, right? We have been supporting our global offices, be it North American market or European market. We have 55 plus engineers in India, right? Who supports domestic as well as global projects. Yeah, these are our products which we have been selling in Indian market. I'll be happy to connect online, offline to discuss more on these products and technology. Essentially, we are very active in municipal and industrial market. Thank you.
Thanks, Sujith, for this presentation. We do have a few questions that I will be taking up that have come up from the audience. So yeah. One of the first questions we have from Anthony Fernandez, he's asking what is the function of the splitter box shown in the diagram that you had given at the start?
Splitter box actually, it's not essential. Splitter box is not essential, but in a package treatment plant, we give those splitter box because with this splitter box, usually you will have 2 MBR streams, right? It's not essentially you will have 1 MBR stream. The splitter box is to divide the flow to both the MBR tanks. Whenever you have multiple MBR trains, you will have those splitter box.
Okay. We have Bharat Londe who is asking a question. Are silicon membranes used only for municipal wastewater or they can be used for industrial wastewater also?
This membrane is more designed for industrial wastewater because of its robustness. You can abuse this membrane as much as you want, right? And you can easily recover those membrane. Yeah, this is a very good fit for the complex effluent where polymeric doesn't work. This will work.
Okay, Ganesh is asking this question. How much calcium in the influent to MBR is good for optimal running?
See, calcium it will also get associated to the total dissolved solids. It depends. Like higher TDS will have the issue with the biological stream, but not to my membrane, right? My membrane is not designed for the see, this membrane is will be acting as a filtration system in any biological stream. The issue will be when the high calcium is there with the biological to grow, right? But irrespective of any calcium component, right? My membrane will get scaled, but you can easily recover it.
So Anurag Tomar is asking a question of how can we develop an anoxic condition?
Without an oxygen.
Okay. Rakesh Mehrotra is asking, according to you, what is the most important attribute required for a membrane for sewage treatment?
Proper designing.
Okay.
One has to have the, yeah.
Bharat Londe is again asking, how much is the COD reduction with a silicon membrane?
Yeah, as I said, it acts as an filtration unit. COD reduction will happen in the biological process, right? It depends what kind of COD is available, right? If you're talking about industrial effluent, we need to check for the non-biodegradable COD component of it, right? Based on that, you need to size your biological process. Usually, whenever you design the biological process in an industrial effluent, always design it based on SRT, not on HRT basis.
Dibya Ranjan Dash is asking, what is the feed limiting condition for the silicon carbide membrane and what is the membrane area available?
See, I don't know which feed limiting condition, whether it is BOD, COD, TSS. I'll answer in general. Feed limiting, there is no absolute feed limiting condition. Depending upon the condition, I can design my system.
Okay. Anthony Fernandez is again asking, when you say SiC membranes are 100% recoverable, does it mean there is no need of a replacement or that the replacement frequency is better compared to other?
See, because these membranes are made out of inert material, it comes out of 8 mm thickness, right? The life is 20 years, right? And we have been giving you 12 years warranty. Replacement can happen. I'm not telling it might not happen because this is a bit of brittleness. If you, let's say during any maintenance activity, if you break any plates, you need to replace. Otherwise, in operation, this membrane plates will never break.
Okay. Sudhir is asking, what is TMP?
It's transmembrane pressure.
Okay. Amisha is asking, how suitable is your membrane for a packaged containerized treatment plant and how automation friendly is the cleaning?
Yeah, it is, since this module comes with 6 meter square area, this is best fit for any modular MBR system. And automation, we can play with the automation, like depending upon the size of the plant, right? There's minimal automation, there's a medium automation, there's a fully high end of automation. We can do that.
Anthony Fernandez is asking, do these membranes break or impact on fall?
Come again, sorry, Mr. Kailash.
Do these membranes break whenever there is an impact or a fall?
Yeah, definitely. It's if you break it, it will fall. Sorry, it will break. It's a ceramic membrane, right? It's like your cup, like the early morning you drink a tea in a ceramic cup, right? If you drop it, it will break it.
Okay. Dinesh Tiwari is asking, how is this different to nanofiltration membranes?
No, nanofiltration is totally different because the pore size here is 0.1 micron. In any nanofiltration, the pore size is 0.001.
Okay.
So it's not a nanofiltration. Yep.
So Sushil Chadda is asking, what is the footprint per MLD?
Per MLD, I would say like compared to conventional, you will have 40 to 45% less.
Okay. Bharat Londe is again asking, does this silicon membrane help in reducing API or antibiotics concentration?
No, but it will not help in reducing, but it can withstand those conditions, right? And get this membranes can be used for treatment.
Okay. Vinod Narkhade is asking, is MBR a replacement to UFRO?
MBR is a replacement to UF, I would say.
Okay, I'll take one final question. Montu Lakhani is asking how far your membrane is comfortable with distillery effluent, where BOD, COD is very high.
Yeah, as I said, like we are not concerned dependent on BOD, COD, because it's a biological process anyway. You're doing it separately. My system does the filtration part of it. As far as you have the proper biological system design done, my system will work. Right? Worst case scenario, it will get fouled, but still you can recover it back.
Okay, Premchandra Shastri is asking, can the silicon carbide membranes exactly replicate the pore size of polymeric membranes?
It cannot exactly replicate because the polymeric membranes has got various sizes starting from 0.01 to 0.08, if I'm not wrong, whereas we stand at 0.1 to the, it's at the beginning of ultrafiltration, I would say.
Okay, final question, Sujith. Ganesh is asking, does any recycled paper mill is currently using MBR with your membranes in India?
Not really. It's a good question. In fact, we intend to do a pilot. We are already in dialogue with a company called Unido, right? They are a governing body for paper mills. Like we very soon will be doing a pilot.
Okay. Sujith, we still do have a few questions, but because of paucity of time, what we will do is that we will send across these questions to you, and maybe you could answer them directly with the attendees who are asking.
Yeah, definitely. I'll be happy to do that.
So thanks, Sujith. Thanks for taking time out and sharing the product specifications and the technology details with us. And we will share, the questions with you. And if I can request, if you can answer them to the attendees directly.
Yeah, sure. It will be my pleasure. Definitely will do that.
Thanks, Sujith.
Thank you.
So moving on to our next session, as I said, we have always tried to do different kinds of sessions which could be of benefits to our attendees and viewers. And it is our extreme privilege and honor today to have with us Dr. Mritunjay Chaubey, Environment and Sustainability Head at UPL, and one of the leading experts in this space. And he's going to talk to us about his latest book on this particular topic. So welcome to you, Dr. Chaubey.
Good afternoon. Am I audible?
Yeah, so I can hear you, Dr. Chaubey. So to start off with the benefit of our viewers, can you give us a brief about this book of yours and what does it exactly cover?
Yes. So good afternoon. And let me thank Smart Water and Waste World to organizing this webinar. Also thank to, I think, more than 400 attendees are there on this live session. So thanks to all for sparing time. So I shall first share brief about my book. The name of my book is Wastewater Treatment Technologies Design Considerations. And it was published by Wiley Publication from their US and UK office. So first maybe 5-7 minutes, I shall brief about the book through one presentation, and then we will have a question answer session. So just I am going to share the book presentation. Is it the slide is coming?
Yes, sir. Can you go full screen, please?
Yes. Yes. So this is about my book, Wastewater Treatment Technologies Design Considerations. And this was published by Wiley Publication. Simultaneously, they are published from their UK office and USA office. Now this book have 7 chapters, and in 7 chapters, I have covered a lot of things. And I can see personally, if you ask from me, I have covered my experience of 30 years in the wastewater treatment. So 24 years I am in the industry and 6 years in academic. So nearly from last 30 years, I am involved. So I thought to write this book. And this book is divided into 7 chapters. First chapter is on global perspective of wastewater treatment. And there I have covered issues related to the water treatment globally. And a lot of things was covered in that chapter. The interesting part is about how the different environmental regulations related to wastewater are in the different part of world. And also I have given some perspective on the deep sea discharge, because when we are doing the deep sea discharge in different part of world, then I found that the regulation is not consistent. And you will see in US something, in UK something, in India something. But as a sea, if you see, as an ocean, then it's going in the common ocean. So that I have covered in my book. And also in first chapter, you will see that I have shared that in last 30 years, how the scenario in the wastewater treatment has changed. Before 30 years, if you see, it was a conventional kind of design based upon just to meet the regulation. But today, a smarter modular design requirement is there to meet the recycling and reuse requirement. In second chapter, I have covered wastewater characteristics. So nearly 30 kind of industry characteristics has been covered in the chapter second. And then in chapter third, wastewater treatment. The fourth is the design consideration. So detailed design has been covered in my book. And fourth chapter is, I think fifth chapter. Fifth chapter is advanced sustainable wastewater treatment. So there you will not find several new sustainable technologies in any textbook right now, like a scale band technology, forward osmosis, volute, and wet air oxidation. Yes, you found, but solar detoxification I have added. So solar detoxification is the new thing. So several advanced wastewater treatment technologies has been covered in chapter 5. Chapter 6 is devoted toward the zero liquid discharge. So that chapter is very interesting, that what all technologies are available for ZLD. And also I have given an overview that what is the techno-economic feasibility of ZLD. And some of the interesting fact I have incorporated, that ZLD may not be environment friendly if you have a proper wastewater discharge facility like common effluent treatment plant, deep sea discharge. Then if there is no environmental benefit if you implement ZLD. So those kind of things also covered in this chapter. And the last chapter is devoted toward the wastewater treatment operational excellence and troubleshooting. So that's about the book. This book is available on all the commercial e-sites, on the Wiley library online it is available. It is also available on Amazon. So you can go on Amazon, just type either my name or book name, you will get the link and you can purchase from there. A part of this, several e-commerce sites, eBay, Red Shelf, and so many, because Wiley has put on worldwide several websites, so very easily available this book from the websites. So now this is about the book. Then now we will go for the question answer session. And this is my contact link. If anyone want anything about my book, then they can contact me. So fine.
Yeah. So Dr. Chaubey, yeah, can I ask a few questions, sir?
Yes, yes, you can ask the question. I think let me show this. This is the book, which is with me. And so, okay, fine. You can go ahead with your questions.
So, sir, my first question is, obviously there have been several books in the market on wastewater treatment. What one is that what prompted you to write about a book on wastewater treatment, considering there is already a lot of books around? And what are the special features in this book that helps it set up itself apart?
Okay. So I think the why I have written this book to answer your question, I think the first thing was in my mind, that from last 30 years, I am involved in the wastewater treatment designs. 24 years in various industry. So I started in Pentair, then I went into Cell, and we implemented several wastewater treatment in refinery of Cell. Then I moved to Unilever. So in Unilever also nearly 500 companies are there around the world. So we came across several wastewater treatment issues and design considerations. And now I am with UPL. So here also globally, a lot of issue comes while dealing the wastewater treatment of agrochemical. So I think that is the main idea, that 6 years while I was in IIT, reading on academic side on the wastewater, and 24 years in the industry. So all 30 years, what experience I get with the wastewater treatment, especially design, operation, new technology. So that let's document, and that is the main idea. Second thing is that nowadays, this is very important to embed the sustainable wastewater treatment technologies. And the sustainable wastewater treatment technologies like you can say volute for the sludge handling, forward osmosis, acclaimed technology, and vacuum distillation. These all are the new technology, and also MBBR is not new, but yes, from 10 years, it's popular inside the industry. So that should be also covered in a textbook, and all design methodology, design considerations should be given. So that was also my idea, and that has been presented in this book. And last point, which is very important, I used to face the problem whenever we design the wastewater treatment plant, we don't get proper characteristics. So when you are going to design the wastewater treatment plant, especially industrial wastewater treatment, then you must know what is the characteristics of inlet effluent like pH, BOD, COD, TDS, TSS. So I have summarized in this book nearly 30 industry effluent characteristics, and that is based practical. Means what characteristic I got while operating those plants, and so practical 30 industries characteristics that has been summarized, and mainly for the FMCG industry, chemical industry, agrochemical industry, and several kind of refinery, and so many more, 30 kind of industries characteristics are there. So I think that is a very good part in this book where any designer can refer those characteristics.
Sir, at the start, you mentioned about the deep sea discharge standards and how they are different in your experience. Can you throw a little bit more light about these deep sea discharge standards?
Yes, I think deep sea discharge is a very interesting thing. And in my book, in the chapter Global Perspective of Wastewater Treatment, I have covered in detail. And what is there, that when you are sending your effluent, treated effluent, into deep sea discharge, then a lot of cost get accrued. And I think it is a very good thing for the wastewater treatment that first you treat, meet the discharge standard, and send to the deep sea discharge. But what I found, that when you see the US EPA norm in US, then their standard is for agrochemical industry, if you see, then they are allowing 4,000 ppm COD. 2000 ppm BOD and 2000 TSS to discharge into the deep sea. But if you see the India standard, then in India, we have put the limit of 250 ppm COD and 30 ppm BOD and 100 ppm TSS. So very stringent. And why it is? Because in India, we have only one norm. Whether you discharge on ground, whether you discharge in the river, or whether you discharge in the deep sea, our norms say that everywhere same standard. But if you see the US EPA, then they have made different standard for the different mode of discharge. So those things has been elaborated in my book, that what US EPA norm is, what India norm is, what is UK norm is, what Brazil. So several part of world has been covered, and it was concluded that in India we have the stringent norm for the deep sea discharge.
Sir, I'll take a few questions that have come in from the audience. So Bharat is asking, does the book cover the treatment of API and antibiotics treatment? Because this is currently a very high agenda for pharmaceutical companies.
Yes, pharmaceutical company I have covered in my book. Even the characteristics also has been summarized. Treatment scheme has been also summarized. And even in the deep sea discharge standard also for pharma industry, what US EPA norm is and what our India norm is, that has been also summarized in this book.
Sir, Dilip Kumar Chatwal is also asking, is the book also covering case studies or literature around sugar plants? Because he says that they are very seasonal and are very difficult to handle before and after the closure of the season.
Yes, sugar industry has been covered in this, and personally I have been with several wastewater treatment plant to treat the sugar industry wastewater. So those treatment approach and design methodology has been covered in this.
Sir, Rupali is asking this book question that can this book be useful for non-technical people also who are interested in knowing more about this industry?
I think it is mainly for them because I have tried to write in such a way that people can easily understand. And I personally feel that wastewater treatment is not just a water management issue, but it is a health issue also. Because today, if you see United Nations Water World Development Report, then as per the report, it's saying that 80% wastewater globally going untreated into the river and in environment. And because of that, one WHO estimate is coming that nearly 2.2 million people killed every year because of water-related and waterborne disease. So I personally feel that wastewater treatment is not a water management issue, but it is also a health issue. And to have a knowledge how to treat wastewater, I have written this book, and it is even for those people who don't have sound knowledge in wastewater. If they will start reading this book, they can also able to design the wastewater treatment.
Dr. Chaubey, Anthony Fernandez is asking that is this book only about technology information, or can it help engineers to design and operate wastewater treatment plants through some examples that you might have in the book?
Yes, so for design, I think 2 chapters has been devoted with examples. And for operators, how to operate the plant. So last chapter 6 is regarding operational excellence and troubleshooting. So the last 7th chapter is fully devoted for the operation of wastewater treatment.
Sir, in your book, while talking about your book, you mentioned about ZLD, and you said that you have an exclusive chapter dedicated around ZLD. Can you share with the audience your views on ZLD based on your experience?
So on ZLD means zero liquid discharge in industry. My view is that in those areas where there is no proper discharge of wastewater treatment facility available and very water scarce location, yes, establishment of concept of ZLD is good for those areas. But it cannot be generalized. Means right now, we are making a general norm that let make ZLD mandatory everywhere, especially in those areas. If you go in Gujarat, coastal area, so we have deep sea discharge facility, we have common effluent treatment plant. So in those areas, I found that ZLD is not a environment friendly technology. And why? Because in my book, I have presented a case study and calculation, and it's showing that suppose if you are meeting just discharge standard, and if you are implementing ZLD, then ZLD consume 4 times more energy. Emission of carbon emission happen 4 times more than the normal discharge standard. Hazardous waste get generated 2.5 times more in the ZLD. And also if you see the capex, it is 2.5 times more and operating cost is 3 times more. So I think the techno-economic assessment clearly saying that ZLD is not environment friendly because it is going to emit carbon emission 4 times more than the normal wastewater treatment, which just meet the discharge standard. And very elaborate one chapter has been included in my book. And so my conclusion is this, that if proper discharge facility is not available, if location is water scarce location, yes, go for the ZLD. But if proper discharge facility available, then it's better to meet the discharge standard and send to the deep sea discharge rather than making it ZLD everywhere.
Sir, we have heard that after the release of this book, that there have been reactions from the Indian government also in trying to, they have given feedback, it seems, about the issues that you have raised in the book. Can you share something about that?
I think, yes, one at Ministry of Environment Forest, mainly on the deep sea discharge and ZLD. So the committee has been set up by the Ministry of Environment Forest to look into the ZLD feasibility, and also a separate committee has been set up to look into deep sea discharge standard. And recently I heard that the Gujarat government has also asked to review ZLD. So I think these two things, two developments happen.
So sir, also a little tricky question, also something that people have put up in my. The question is that don't you think that the book is a little costly? You know, you're talking of nearly 8 to 10,000 rupees. The feedback is that the book seems to be a little expensive.
You are right. I think the 10,000 rupees, yes, at Indian context, it is costly, and my aim was to make it cheaper. But the problem is that Wiley has published this book, and that is a US, from US and UK. And if you see the Wiley, they are very renowned publishing house for the technical book around the world, and their technical books start in this range. Means in Indian maybe $100 US dollar. This book cost $120 US dollar. So between $100 to $150, it's normal cost by the Wiley publications. So cost was not in my hand, and truly speaking from me, yes, we should make it affordable. But right now it is beyond my control.
Okay. Sir, one final question is that while this book seems to be very, very useful for the wastewater treatment designers, do you think that, there could be a lot of information and data in this for even the operators and
I think your voice is breaking.
Yes, sir.
So just
Mr. Chaubey, I'm not sure if you can hear me.
yes. Now I am hearing. Now I am hearing. So yes, if you see for operator, this book is very good for the designer, but also it is very good for the operator, because the last chapter number 7, I have covered wastewater operation excellence and troubleshooting. So that chapter is very good and relevant for the operators, and there they can able to see that how to make the logbook and how to analyze the characteristics. Also, while operating the plant, what care they should take and what kind of parameter they should use to measure. Also, nowadays we have to implement online measuring instrument. So those things has been also covered in this book, how to install the online instruments and how to measure the online all parameters. So I think for operators, this is very good. And they can also, when they will read this book, then they will also found very useful.
Thank you, Dr. Chaubey, for taking time out of your busy schedule and sharing about this book. I'm sure the community at large will benefit a lot from this book, and hopefully we will have many such books from you in the future, sir.
Right. Thank you. Thank
So
you.
we will share with all our attendees today all the details on how you can, procure these books. We will share the links of where it is available. And in case anybody wants to reach out to, the doctor directly, we would be more than happy to share his contact details. So thank you, Dr. Chaubey, for this session.
Thank you. Thank you.
Moving to our next session for the day today, I would now like to invite Colonel Bhaskar Tatwawadi. He is the director at Double Shotz Pte Ltd. And he's going to talk about the understanding process water requirements and management. Over to you, Colonel Tatwawadi.
Thank you. And good afternoon, good evening, and good morning to my friends in India and Canada. I would like to begin this discussion with a very small PowerPoint presentation, and then we will move on to the questions and answers. Is my screen visible to all?
No, sir.
No, sir, you will have to
Click on the
Just
share
hold.
screen button. Click on the share screen button and share it.
Just a moment. Is it now visible?
Yes, sir, it is.
Okay. So understanding process water requirements and management for the water required by the pharma and the semiconductors industries. In other words, the requirements for ultra pure water is what I'm going to discuss today very briefly in this second season, 4th episode of the IWET series. At the outset, I thank Mr. Kailash Shirodkar and his team at Smart Water and Waste World for giving me this opportunity to share some of these requirements for very, very high grade ultra pure water, which is required by these industries. I shall start with the pharmaceuticals industry's water requirement. And I think it is always a good idea to start with the market size of the particular industry about which we want to talk. Now, there are some figures about the pharma industry, which say that the global production in 2021 was $486 billion, and it is slated to increase to $958 billion by 2028 at 11.34% at 11.34 CAGR. Of this, the Indian production component was about 42 billion in 2021. Now, when the market size or the revenues are talked about, the 2021 revenues increased to 1.25 trillion from 1.22 trillion in 2021. We are all undergoing the third wave of the pandemic, and the pharma sector has seen a boost during the pandemic, and quite understandably, with our Indian share of the production and the logistics of supplying the several millions and billions of doses of the vaccines, the government of India has now decided to boost the sector and has permitted foreign direct investments up to 100% for manufacturing medical devices. The focus is on cost efficiency, economic drivers, and by way of policy supports and investments, including FDI. Now, all this is going to have a direct impact on the water required by the pharmaceutical sector. There are several guidelines and directives on the water quality required by the pharmaceutical sector. Water for pharmaceuticals use, WPU, is a term which is very commonly used across the industry. A working document in May 20 was issued by World Health Organization. It was titled Good Manufacturing Practices, GMP, Water for Pharmaceutical Use. And it basically focused on the production of pharma grade water for injection, which is also called WFI, by means other than distillation. You see, earlier, distillation was considered the only process to produce water fit for injection purposes. Now, with the advent of several other physico-chemical processes other than distillation, we have multiple options to reach the same level of purity. The important thing about the pharmaceutical water is the microbiological and the chemical quality of water, which has to be controlled through the several stages of production, storage, and distribution. There are two major pharmacopoeial requirements and which provide guidance for production of WFI. The international pharmacopoeias are basically from Europe, that is the European pharmacopoeia and the US pharmacopoeia. They give the requirements for bulk purified water, bulk highly purified water, and bulk water for injections. The European Medical Agency, or the EMA, guidelines were issued in 2020 to cover these grades. And in this table, I have listed the parameters for purified water as well as water for injection, both by the European Pharmacopoeia and the United States Pharmacopoeia. They list total organic carbon, conductivity, nitrates, heavy metals, aerobic bacteria, and bacterial endotoxins. And there are slight differences, yet the quality of the water required generally remains the same. I'm not going into the process details right now about the production of these grades of water. We'll touch upon that a little later. Now, first, I will talk about the water requirement of the semiconductors industries or the semiconductors sector. Here again, if we go by the global business in the semiconductors, it rose from $426 billion to $452 billion in the last year, and is expected to grow to $803 billion by 2028. You see, everything that we do, including this presentation which you are watching, and the electricity which comes to your home, these several gadgets which we use, the automobiles, the cell phones, you name it, and the semiconductors are there in every, they form a component of all the gadgets, every machine. And in addition to that, they are also vital for the growth of artificial intelligence, Internet of Things, and machine learning. Consumer goods, including your refrigerators, washing machines, anything that you have that you use in your homes, they use these semiconductors. In the Asia Pacific region, the semiconductors market growth from 2020 to 2022, the 2 years, is expected to more than double and rise from $230 billion to almost $573 billion. When we talk about India, the Indian market size, which was 113,000 crores in 2020, is expected to grow to 470,000 crores Indian rupees by 2026. And considering that due to the pandemic, there have been several logistical disruptions in the supply chain of semiconductors, the government of India has taken upon itself to encourage the growth of semiconductor industry in the country and has invested. It is going, has declared its intention to invest $10 billion and to also provide incentives to the tune of about $30 billion in the coming years. When we talk about the global players, the most important players in the semiconductor industry include the Taiwan Semiconductor Manufacturing Company, Intel, Broadcom, Qualcomm, Samsung, Toshiba, SK Hynix, NVIDIA, and NXP. There are several other smaller players, but these are the ones who rule the market. Now, we must all understand that the ultra pure water which is required for semiconductors manufacturing is a step ahead of the water required by the pharma industry. And now I will just run you through a typical scheme of ultra pure water production. And this system requires an integration of several treatment technologies, including reverse osmosis, electro-deionization, and ion exchange. The pre-treatment starts for the drinking water or the water which is fit for human consumption, which is used as feed water. It's pre-treated, then it goes through a heat exchanger, goes through 2 passes in series of reverse osmosis 1 and reverse osmosis 2, degasified, has its first shot of ultraviolet radiation 254 grade, and then it is subjected to ion exchange or electro-deionization. It is again passed through a second level of ion exchange resins and then stored in ultra pure water tanks. Before use, another dose of UV radiation 185 grade is given. Deionization by another ion exchange bed is done, and finally it has to pass through an ultrafiltration filter for production. Now this is the process which starts with drinking water and ends in the ultra pure water which is required for production of the chips. An ultra pure water plant looks something like this. This is a picture of the Hynix ultra pure water plant. I will give you just a few details about the quality which is required for the production of chips. These details include resistivity at 25 degrees, the concentration of ammonium, bromide, chloride, fluoride, nitrate, nitrites, phosphates, sulfates, calcium, lithium, magnesium, potassium, and sodium. The point to note here is that these are all represented in picograms per milliliter. So you can imagine the kind of water that is required and which is ultra or super ultra pure water. As far as the semiconductor industry is concerned, about 100 million liters of ultra pure water is used daily for the production of semiconductors. This is as per the available information, but this number is going to increase by another 4 to 5 times in the coming years. There are several quality management issues when we talk about the ultra pure water, because when you see the level of purity that is required and the concentration of several impurities, and you also see the entire process of purification, you will understand that through the process of purification, followed by its transport or its journey through the several pipes and pipe fittings and its storage, there are issues related to its quality, and its quality has to remain steadfast through the entire process. So the quality management issues start with production, process selection, and the output. Prevention of changes in the physicochemical attributes is most important. In the post-production storage, it has to be in sterile environment. The material of the storage tanks is very important. Similarly, the piping and spatial quality is vital. And then when it is flowing into the tubes, during distribution, during the production process. The flow has to be continuous. There have to be online quality checks. The wastewater has to be isolated. It cannot be permitted to mix with the ultra pure water. The wastewater has to be collected, effectively removed from the process sites and treated. And the EMP, as in the European Management European Practices Guidelines for pharma sector and the SOPs for semiconductor manufacturing units. They govern the ultra pure water quality management from its production to disposal stages, and these have been elaborated in the several pharmacopoeias as well as these guidelines. That is the end of my presentation here. My contact details are here. Now we can go to questions and answers. If you have any questions, I will be happy to answer.
So, Colonel Tatwawadi, one, thanks for sharing the complexities involved, in the water quality required for the pharma and the semiconductor industry, and also the opportunities involved. So, a query that I have is, how does this production of ultra pure water, differ from the normal drinking water? I mean, we saw the different stages, but if you could tell us what is the essential difference between an ultra pure water and a normal drinking water?
Yes, the ultra pure water process starts where the drinking water treatment ends. So as far as the drinking water treatment is concerned, there are standards given by the World Health Organization. We have our Indian standards, which normally follow the WHO standards. And when we do treatment for drinking water, we have a set of processes. And then when the end product, what we call is the drinking water, is normally supplied by the municipalities like the MCGM, and it is supposed to adhere to certain quality standards. Now, this drinking water is the raw material for production of ultra pure water, and therein lies the difference. So the end of the treatment process for drinking water is the beginning of the process for production of ultra pure water.
So, sir, considering now the complexity of the treatment processes that you have just shown, now, what is the likelihood then of capacity expansions in the pharma or the semiconductor sector? I mean, the semiconductor is a completely new sunrise sector, but considering this complexity, what is the scope for the growth or capacity expansion in the pharma sector?
You see, the semiconductor industry, like pharma, has certain gradations. In pharma, we have the bulk drugs, which are produced with normal drinking water quality. And then we move on to the purified water and the water for injection. So these are gradations of water which are used in the pharma industry. Likewise, when it comes to the semiconductor industry, there are gradations of semiconductors, and the highest and the purest or the ultra pure water quality is used for the highest grade chips, which are then utilized, which have certain applications. However, the chips which are used in our day-to-day operated machines, the home appliances, they are of a slightly inferior quality, and therefore these do not require the ultra pure water quality which comes out of the process diagram which I showed in my presentation. Another thing is that there is an incentive by the government to set up the semiconductor plants in India. And again, I draw a parallel with the pharma industry. Why the pharma industry has grown in India is because we started with the production of bulk drugs, and then these bulk drugs were exported to the entire global community, including Africa. And that is how the revenues came. And the industry had enough money to go in for sophisticated research and development. Similarly, as the semiconductor industry starts operating in India and starts producing the bulk grade chips which are used in manufacturing, then it will be easier to move on to sophisticated manufacture, and the ultra pure water requirements will increase gradually in relation to the kind of production that we are looking at.
So, sir, a query I have is, we talk about the growth of the semiconductor industry in India. The government has also announced, I believe, a 76,000 crore package for the semiconductor industry in India, and I believe that 20 leading business houses have already given expressions of interest that they want to set up these factories here. So, what are these location-based constraints that could be there for the development of these semiconductor factories in India?
Yes, this is an excellent question. Actually, if you see the quality of water that is produced or the ultra pure water that is required by these industries, the important thing to note is that the air quality or the ambience within the factory or the ambient air quality within the factory has to be absolutely sterile without a speck of dust. Similarly, water has to be available. The air surrounding has to be extremely clean. And there are several issues related to the climatic changes, the temperatures, the microclimate management, and therefore the locations ideally should be away from habitation. But as per the information which is available, some of the likely locations are the National Capital Region, which is, to my mind, an absolutely unsuitable location. There could be some other locations in Gujarat or down south in Bangalore. Some of the factors governing also include the presence of the multinationals. For instance, Samsung is there in NCR, and the Samsung is one of the major players in the semiconductors, and there are several Indian companies which are in different stages of negotiating with the Taiwan semiconductor manufacturing company, and eventually where these plants come up is anybody's guess.
So, sir, I'll take a few questions from the audience. So, Dibya Ranjan Das is asking ki, why is the heat exchanger required? Do we need to maintain a specific temperature during the treatment?
There is a removal of what is known as pyrogens involved. And that is why that heat exchanger is required.
Okay. Mr. Ravi Chandra Singh Jankar is asking, do you know of any OEMs active in providing plants for ultra pure water?
There are several process manufacturers who are producing, again, packaged plants for pharma as well as for the semiconductor industry. As I said, the entire gamut of the processes shown in my slide is not always required for the semiconductors, which may be of inferior grade. So yes, I know of some vendors who are working to provide these packaged plants, combining several processes on the same skid.
Okay, so Meena Ketan is asking, is ultra pure water similar to distilled water?
It is, I would go a step ahead and say it is better than distilled water.
Okay. Braj Mishra is asking, what are the instrument techniques for detecting pico level of impurities?
most of the instrumentation involved in this and the measurements is through online sensors. And such sensors are available because as the standards are prescribed, there is no what should I say, rationale in prescribing standards which cannot be measured. So yes, it is possible to measure these using spatial sensors.
Okay, Mohammed Nazir is asking what is the conductivity difference in both the waters? So I'm assuming ultra pure water and normal drinking water.
It could be of several times. For the ultra pure water, I have mentioned in the slide in my presentation. So it could be 10 times, 20 times, 30 times, even more.
Okay. Montu Lakhani is asking the question saying, sir, if we consider a chips factory setup, what is the budget for ultra pure water treatment plant? And what is the ratio for production with water generated? I mean, I don't know if you have this data offhand.
I was reading somewhere that a 300 mm chip typically uses 1000 liters or 1 kiloliter of ultra pure water, which in turn could be coming from at least 20 to 30 kiloliters of normal drinking water. That is as far as the water is concerned. Now, if he's talking about this, the setting up of a semiconductor plant, I won't hazard any guess.
Okay. Sir, Dibya Ranjan Das is again asking, what is the temperature to be considered to remove spirogen?
Typical values which are given for the testing of ultra pure water is 25 degrees Celsius.
Okay. I'll take this final question, sir, from Vasant Kothalkar. He's asking, are there any set parameters for ultra pure water?
I have mentioned in the slide what are the parameters.
Okay. We will share the presentation with all our attendees.
Yeah, kindly do that.
Varun Shukla is asking, is there any wastage of water when you are producing ultra pure water?
You see, yes, of course, this water, I mean, the entire 1000 liters of ultra pure water, once the chip is produced, becomes wastewater and has to be recirculated, reclaimed, treated, and reused.
Okay. I think people are just sending in the questions here. How do we then manage it? I mean, if this entire 1000 liters of water, yes, after the chip is manufactured, you said it either has to be discharged or reused, right?
Yes, it has to be reclaimed using the same process. It would, even the wastewater produced in the manufacture of semiconductors, perhaps would give us wastewater which is better than our drinking water quality.
Okay. So Colonel Tatwawadi, thank you very much for taking time out of your schedule and sharing this thing for us. I'm sure, I think our attendees have now realized that maybe while we knew pharma was always a good sector, but I think there could be many opportunities going forward in the semiconductor sector. I think Sujith wants to come in.
Yeah. Colonel Bhaskar, it was a really fantastic outlook which you have given about semiconductor industry. Ovivo is one of the preferred supplier for semiconductor industry. We have been working with Intel, the Taiwan semiconductor manufacturing unit. I don't know like how we can have collaboration in Indian market. I'll just connect after this call to understand like how Ovivo can add values in association with you.
Most certainly, sir. Thank you very much.
Sujith, I will share the details for Colonel Tatwawadi with you, and I would leave it, the two of you to take it up from there. So this brings us to the end of the fourth edition of the IWET series. We have in this particular episode tried to do a little different from the typical technical presentations that we have been following. And I hope that, these sessions have been relevant to you. And, I would look forward to any feedback from you in case of, should we continue these kind of sessions more, or, we should go only for, the typical technology kind of sessions. I would like to thank all of our speakers, Sujith, Dr. Chaubey, Francis, Colonel Tatwawadi, and Yasmin, for taking or being with us throughout the entire sessions and taking time out and sharing their knowledge with us. And most importantly, a special thanks to all the attendees, for supporting the IWET series over the last, I would say now close to around 10 episodes that we have done in the last 1 year. We look forward to your continued support. We will have 2 more episodes till we finish season 2 at the end of March. And then, like always, we will take a small break before coming back with season 3. So looking forward to your continued support, and we will look forward to joining you back again in February. We will announce the dates soon. So thank you all for this session.
Thank you so much. Thank you. Bye-bye.